In this video, we'll be taking a look at the data logging methods that are available to us within the Virtual Robotics Toolkit. Now, there's 4 methods in total. 2 of those methods can be found within the simulator. The other 2 methods are native to the LEGO Mindstorms EV3 programming environment. We'll be looking at all 4 in this video. So without further ado, I'm in the sandbox project, and what I'm going to do here is I'm going to add some sensors to my default sample project robot. So let's give this a click. And I'm going to come up here to the attachments dialog, and I am going to add an ultrasonic sensor. And we can see that this is going on the front of my robot, so that's a great place for it. I'm going to add a color sensor. And lastly, I will add a gyro sensor to the back. And we can see that it shows up here. I will hit OK to save my changes. So my robot, we can see now, is modified. It has the 3 sensors that I've added to it. And let's discuss the first 2 methods, which are tools that are found within the Virtual Robotics Toolkit. So I'm going to hit play to start the simulation. You can see that when I hit the play button, I'm getting what looks like a laser coming out of the ultrasonic sensor. And basically what this is it's a visualization or a representation of how the ultrasonic sensor works. So for those who have an understanding of this, basically what's happening is one eye on the ultrasonic sensor is emitting a high-pitched ping, and the second eye on the ultrasonic sensor is listening for the echo. And the time differential between ping and echo is how the ultrasonic sensor is able to determine the distance of objects that are in front of it. So when there's a longer difference between the time and the hearing of the echo, we know that an object is further away. So in this case, the ultrasonic sensor is looking at the wall, and then that echo is coming back to the other eye and being recorded. Of course, as the robot gets closer to objects, the time between ping and echo gets shorter, and that's really how the sensor knows that there's something in its way. So let's demonstrate that by driving the robot around. You can see that as I get closer to objects, in particular the corner walls here, that these colors get warmer and warmer. So when we started out here, my color sensor was green and in some cases blue. As I get to the wall here, my visualization has turned yellow, orange, and eventually gets to red. And that's probably the easiest way to do data logging within the sim. Now, for things like the color sensor and the gyro sensor, there are no visualizations. Well, there actually is a visualization for the color sensor. It's just really, really hard to see. You can see that if I come, I'm actually looking through the map. You can see how the ultrasonic sensor, the color sensor, it has a light of its own, but it's not very useful to us in this instance. So let's talk about the real-time data window, which is the second method that we can use to get information from the simulator. So I am going to click on this button up here. It looks like a radar, and it is our real-time data window. Now, don't be intimidated by the window. There's a lot of useful data in it. And basically what the real-time data window is giving us is information from our 3 sensors. So we see the ultrasonic sensor, our left color sensor, and the EV3 gyro sensor. We're also getting information from the 2 motors. You'll recall that there's an embedded sensor within the motors, and that information is coming here. So in the context of the ultrasonic sensor, you can see that as I get closer to objects, how the values in here are getting smaller and smaller and smaller. And what these decimal values are supposed to represent are values in centimeters. So, and at some point, the ultrasonic sensor, I believe, has a threshold value where it doesn't see too much underneath 10 centimeters. So we can see that the readings here get a little questionable. But nonetheless, a useful tool for getting an appreciation for distance. We can see here with the color sensor, it's recording those values on an RGB scale. This last digit here represents transparency. So you can see that as I move from the white mat to the blue corner, how these RGB values change. And again, I could come up here to the green mat in the corner and we should see different values still. The gyro sensor, which we know measures rotation around an axis. So as I turn the robot in one way, there's an invisible axis here, and we can see how we're getting positive values. And then if I turn the other way here at the angle, we're going to get negative values, right? So now we're getting negative values. Those are the tools within the Virtual Robotics Toolkit. Of course, if you've done any kind of physical Mindstorms programming before, you're probably most used to working with the tools available within the LEGO programming environment. So let's take a minute now to see how those work. I am going to stop the simulation and just get rid of this window. I will call up the EV3 virtual brick. So here I will call up the intelligent brick. I will turn it on, and this should look pretty familiar to most of you. I'm going to tab over to the virtual brick port view and hit the middle button. I don't have anything plugged in on port number 1. If I go to port number 2, I have my gyro sensor, and I am going to just make the robot drive so we can see how we're rotating in a positive manner around our axis, which is in this case likely our y-axis that's running up and down. And then if I go the other way, we're going to get our negative values eventually here. Okay. Next up, if I tab over to port 3, I have my color sensor. So the color sensor here right now is showing reflected light intensity. So we're on this very bright white mat, so a lot of the light is being reflected back to the photoresistor that's within the color sensor. If I come to the red mat here, we should have seen values change, but let's try this here if I go to black. Okay, so black's a better example here where I'm getting a very low reading back from the black mat. Our ultrasonic sensor again is giving us distance in centimeters. So here as I get closer to objects, we can see how those values go down. And as I open up and look at the rest of the board, these values become larger. Lastly, we can get all of these values reported from within the Mindstorms software itself. So I'm going to open up the LEGO EV3 software. It doesn't matter whether you use the education version of the program or the retail version. Both versions of the EV3 programming environment work exactly the same. I'm going to create a new project here. And if I go down to the bottom here where there's a list of available bricks, ordinarily if I had a physical robot in, we would see it, but what we're finding here is it's actually finding our virtual EV3 educator vehicle. If I come up here to the sim, we can see that the virtual robot is called EV3 Educator. And so it's finding that robot. And if I go into port view for it here, first let me actually connect to it. So now if I go to the port view here, we can see the values for the gyro sensor, the color sensor, and the ultrasonic sensor. And I'm just going to drive around the mat. So we'll make a mental note here that there was a value of 378, 92, and 105. Let's just take this for a spin here and see what happens here when I go into the corners. Now I'm in the black corner, so we should be getting a different reading for the color sensor, the ultrasonic sensor, and in the process of turning, I may have affected the gyro sensor values. And now we can come back that we have substantially different values for all three sensors. So those are your 4 methods of data logging.